Hi, my name is Sam. I'm on a mission to make transport sustainable using the power of steam. During the last couple of weeks, I've explored an alternative use for steam, which simply strengthens the case for steam locomotives. But before doing that, I had to finish roughing out the steam pump cylinder liners. Okay, I've got both of the cylinder liners roughed out now. Went quite well, quite pleased. Took a bit longer than planned because I had to make a boring bar to bore the larger liner, but that'll be quite useful later on when I'm finished machining the bores of both of them. So now I can get on to cutting the steel pipe for the cylinders, and I've got to get some orders out for laser cutting the flanges to fit on each end and some of the other components. Now, because I don't like using glyphosate, I've asked Nico's wife not to spray the weeds and to leave me to deal with them, which she's kindly done. So now I've got to deal with them. But I've asked to do it because it's a good opportunity to try out thermal weed control. It's something that I tried years ago using the small prototype boiler, but never had really enough steam from that to make a good go of it. Now I've got plenty of steam, and I think it's time to give it another go. Of course, thermal weed control requires a lot of energy, and thermal weed control is used more and more so because it does eliminate the need for glyphosate. But if it's using diesel fuel, then that's just releasing unnecessary emissions, and diesel's quite expensive on an energy basis. So having a portable wood-fueled boiler is quite valuable, and it's something I want to explore a bit closer going ahead. So typically for steam weeding, the steam is passed through a flexible hose to the applicator, but this boiler generates superheated steam, and steam hoses can't handle 400 degrees Celsius. So this steam needs to be de-superheated, and the way to do that is to inject a small amount of water into the steam flow to cool down the steam. So what I've come up with is a fairly simple injector. Basically, it's not an injector in a conventional sense which pumps water up to boiler or above boiler pressure so it can feed water into the boiler. This only has to pressurize the steam to about 90 psi, or not even that. Earlier today I quickly got this drawing together, and basically superheated steam enters here. It expands through a convergent, divergent or de Laval nozzle, attains supersonic speed. At that point it draws in de-superheating water, and then it's directed into the flexible hose. So it sounds fairly simple, but there's a number of reasons why it may not work. So we'll just have to try it and see. I've got a short bit of, I think it's 1045 in the lathe. Bit of history in this piece, and you can probably see St. Thomas of Canterbury College written on it. This originated back when I was at high school, and I brought a bit of stock home for the gas turbine I was developing at the time. So I'm going to turn the OD and then bore out the opening for the steam nozzle, and then start boring out the nozzles. So after multiple failures, I ended up grinding down a fairly old piece of high-speed steel to form a boring bar to bore out the 7mm bore and machine the taper. Nico and I are on our way up to Springfield for a working bee at the Midland Rail Heritage Trust site. Yeah, like that. Yeah.
Window.
So the Midland Rail Heritage Trust was incorporated about 15 years ago. Nico and I became involved just 4 years ago as trustees. The trust has been relatively inactive over the last 7 or 8 years, so we're just now starting to get back into some track work, and one day the idea is to operate small weekend trains in the yard up here. Oh well, it was a good day at Springfield. We got some track out of the way. Next time it should be quite straightforward. Get some more sleepers down and start laying the leading leg. Nico and I are on our way up to Springfield again. Last time we got the site cleared, and this time we're going to start laying some rope. What are you doing, Simon?
I am bending rail using a Jim Crow. Make a curve in the rail, put pressure in the centre, tighten it up to the correct tension, to get the curve set, and then release it.
I thought I'd take the opportunity to have a look at these two UC class locomotives that were pulled out of the Grey River on the west coast in the mid-2000s. The intention was to return these locomotives to mainline service, but the locomotives are in a really bad shape. It's really interesting looking at some of the design features, and especially areas where there's a lot of wear. Tells a lot about some of the maintenance difficulties that may have been experienced. So New Zealand Railways dumped these locomotives as a part of a riverbank protection scheme, but it has preserved some interesting features, such as the wear on the plate frame due to the back of the flange contacting it. The frames are perhaps 3/4 inch, maybe inch plate, and it looks like at least a third, if not more, of the thickness has been lost around the firebox here due to the back of the flanges. So the firebox is hard up, just about hard up against the plate frame. So this frame would have been at the same temperature or thereabouts as the water in the boiler, which would have introduced quite a lot of thermal expansion between the rear drivers. And taking a look between the frames, it appears the frames were planed. You can see the tool marks. The axles had collars on the inside to carry the lateral thrust of the drivers, a design that was thrown out after some time because it tended to sling the oil out of the driving boxes. A very interesting arrangement on NZR locomotives is the design of the superheaters. The large holes in the tube plate carry the superheater flues, in which the superheater elements are inserted, and typically these would run horizontally, and all of the smoke tubes or the fire tubes would be carried beneath the superheater flues, not up the middle. Now I understand this design was used to get around the superheater patents that were in force around the time that New Zealand Railways began installing superheaters, and that patent covered the use of a superheater header in the upper section of the smoke box. So this used two headers set into each side of the smoke box, and that got around the patent. I'm not sure how well it worked, and one issue in particular may have been significant heat loss because the headers protruded out the sides of the smoke box directly in the airflow, so no doubt it lost a bit of heat there. Well and truly, washout plugs are still there. Well, this is what we got done today. So we started at this joint. Obviously it needs to be lifted and aligned, but it's a good start. So this is going to connect with the other end of the triangle. Down here. That's roughly the centre line of the track, so we've got another curve at this end to connect with this existing curve and back to the turnout. So once we complete this section of track, it's going to allow us to use, or at least ballast, the triangle, which runs into the distance. The turnout lever can be just seen, and then comes back under the two UC class locomotives and to where we started. A good day in Springfield, finally some progress. We got some 20 odd metres of track laid, which doesn't sound like much, but there was a curve on that, and from where we were starting, it's the first bit of track we've laid, or I've laid while I've been with the Midland Rail Heritage Trust. So happy with progress today. I'm back at the Canterbury Steam Preservation Society for a Sunday running. So first Sunday of every month the Preservation Society runs steam trains and opens up the Steam Museum. It's a week after the night run, but the weather's good, and because we haven't run for so long, we're trying to run as much as we can to catch up a bit. Today I'm booked on as the driver, and with me I've got Andrew. This is his first day firing this locomotive. Firing's not the easiest thing to learn to do, and he's making a good job of it. So it's an extra hard day because of the fire risk of running with the damper shut to try and mitigate any sparks that might be thrown.
Just feel a camera on there. Dot there. Regulator is closed. Yes. Reversing lever in mid position. Yes. Don't let my wife see this, eh?
No.
I claim I can't do this. I don't know what I'm doing.
I've got to remember to look at what I'm doing instead of the camera.
This one?
Yes, please. Now that looks weird. Someone else is doing it, so you can do it now.
This one been done?
Yep.
And that one? That one isn't, there isn't one there, this is a nut. Action.
Okay, all the parts made. This is the steam nozzle, or the expansion dealer valve nozzle. We have the flanges for the ends and the injector body itself with the diffusing cones. So I'm going to assemble it now with some anti-seize, put it on the boiler, and we'll give it a go tomorrow after I've made the applicator. All done. So this end discharges into the steam hose to the applicator and to the weeds, and this is the superheated steam inlet. The applicator is very simple. It's a bit like a weed eater in some ways, and I'm starting by folding up some 25x3 flat for the applicator handle. Dean's lent me another tool, this very handy press brake attachment for the hydraulic press.
Can't see. I'm in the sauna. Well, I can see what I'm doing.
Well, we killed some weeds, or we think we did. The injector worked, but not as well as I'd hoped or needed it to. So I need to make a few adjustments to that. But we were able to try out the weed killing, and I was really stuck on designing the injector for some more data. So I've got that now, and I'm going to try out a slightly smaller steam nozzle to see how it performs, how the characteristics change. We also established that slightly damp or relatively dry steam applied to the weeds was a bit difficult for the operator to see the weeds, and it seemed that using superheated water tended to be more effective and a bit easier to apply. So I'll be making some modifications to the design to facilitate that, and we might give it another go in a couple of weeks' time. Okay, so we are just under 24 hours after making the application of steam and ice spice and dead weeds. For a first effort, I think that's a success. Dying weeds. Well, that's it till next time. Look, a huge thank you for watching these episodes and supporting the project, and an extra special thank you to those of you who have joined the project as patrons. I really appreciate your support. If you haven't already, please subscribe and check out my page on Patreon. I'd love to have you on the team as a patron to help me on my mission to make transport sustainable using the power of steam.